Hey kids, so today we're going to talk about acceleration on a hill, how we can find that, how we can solve for it, and what it actually means. So right here we have set up this experiment. We have this ramp, it's marked 1.5 meters to the ground, meaning that when we let go of this ball, it's going to travel 1.5 meters until it hits the ground. What's important to remember about this is that this ball is rolling. If it's rolling, there's no friction. We don't take into account friction when items are rolling. So what we're going to do in a second is I'm going to let go of this ball, we're going to time it, and then by timing it, we're going to find the acceleration, and when we find the acceleration, we can also find the angle. So let me ask you this, what formula should we use if we know the distance and we're about to find the time to find the acceleration? What's the shortcut formula? That's right, it's xf equals 1/2 at squared. We can't use any other, we don't want to use the first half of that because there's no initial velocity, right? It starts from rest, so that equals 0. So xf equals 1/2 at squared. So I'm going to let this go. I want you guys to time it at home. Remember, just play it back as many times as you need to get the right time. So here we go. Ready? 3, 2, 1, go. Stop. So time that. Tell me what you get. Good, so hopefully you got that right. Me and Mr. Perkins timed it out a lot, and we got 0.7 seconds. So this ball traveled 1.5 meters in 0.7 seconds. So what acceleration did you get for this ball?
We're rolling.
So I'm drawing this is what the board is, right? So we have our floor right here, and then the table is sitting right there. So this is our board sitting on our table. It's 1.5 meters down that way, and it took the ball, as it rolled down the hill, 0.7 seconds. Now, we said that xf equals 1/2 at squared, so our 1.5 is equal to 1/2 a times 0.7 squared. So this turns into 3 is equal to 0.7 squared equals our A. And so our A is then equal to, so calculating it out, we get A is equal to 6.12 meters per second squared. Hopefully you got that. So now let's try and figure out what this angle is, right? We have an angle that this ramp made with the floor. So how are we going to figure that angle? So our acceleration from this ball is due to this angle right here. Let me explain. If I hold this straight up and down, what's the acceleration for the ball? Good, 9.8, right? It's going straight up and down. It's only gravity. Now what if I do something like this? Then what acceleration is this ball having? Nothing, right? It's not going up and down the ramp. So the acceleration of this ball on this ramp is due to the sine of the angle that the ramp makes with the ground times gravity. And that's how we solve this. So now let's check our work. We said that this ramp is 1.5 meters to the ground, right there, and we measured it out to be 93 centimeters or 0.93 meters straight up and down off the ground. So let's use sine to find our angle, knowing that.
1.
Okay, so we want to find out what this angle is. We know that sine is equal to opposite over hypotenuse. So our sine of our angle is equal to 0.93 over 1.5. To get this angle, we're going to say our angle is equal to the inverse sine of that quantity right there. So let's do that real quick.
Yeah.
So we got an angle, 38.3 degrees. Now let's check and see if our acceleration that we got was right. We'll just say our acceleration is then equal to g sine of the angle. So we'll write that as 9.8 times sine 38.3. Yep. All right, so what do you get for this? What do you get for the acceleration when you solve that out? So 9.8 times sine of 38. Go. All right, so I did it on my calculator, and I got this answer right here. I'll write it over on this side. 6 0.1 meters per second squared. Look at that. Checks out. So our work was good.